Good afternoon, guys. Good afternoon, one and all. Today we are in the lecture 22 of fluid mechanics. So today we are discussing the topic called Bernoullis equation and the momentum equation with respect to Bernoullis equation and the forces acting in the pipe wherever it is having a bending. So whenever a pipe is in a bent portion, how the forces are acting. So these we will discuss in this session. So maximum will end this unit 2 in this session 22, right? So apart from that, so wishing you a happy engineers day, right? So the topics what we have covered up till now is from fluid mechanics up to here we are completed. So yesterday we have discussed about the Euler's equation and some of the problems. So we will discuss the Bernoullis equation, the momentum equation and their applications, and the forces acting in the pipe bends. So with this, the unit will be completed. So maximum will try to complete now. So be patient and listen the topic. So today is a engineers day. So wishing you a happy engineers day. So actually, among all the engineering branches, the oldest branches of engineering or mechanical and civil engineering branches, right? So between these two, mechanical and civil engineering, who is the father of engineering and who is a mother of engineering? So if you know that who is the father of engineering, mechanical engineering department is a father of engineering and civil engineering is a mother of civil civil engineering is a mother of engineering. So with this two, we can conclude that mechanical is a father of engineering, father of science, and civil engineering is a mother of engineering. So both are very, very important, not from today, from the ancient days, from the ancient days, industrial revolution, before PC and AD, right? The historical age. So we don't know about electronics, we don't know about motor, we don't know about the other things like what is a motor, what is a transistor, what is a diode, what is electronics. We don't know anything, right? So only mechanical and civil engineering are existed in those ancient times. So how to prepare axe, how to prepare bow, how to prepare stick, how to prepare different vessels, right? How to construct with the stones, how to construct with the mud house, how to construct with the different metal, different metal objects. So these are all civil and mechanical engineering are together combined to form the engineering, right? Now we'll see. I think only 2 students were present. I'm hoping other students to come. Snehalata, good, right? So here we'll continue the fluid mechanics. Already we know that the study of fluid statics and fluid dynamics, and also the fluid kinematics. Did we discuss the study of fluids in motion where the pressure forces are not mentioned or considered? The fluid dynamics, the study of fluids in motion where the pressures are considered, right? Now, what is the dynamics of fluid flow? The dynamics of fluid flow is subjected to several forces which result in the variation of acceleration and energy involved in the flow of the fluid. The study of the forces and energies that are involved in the fluid flow, the study of the forces, the various forces involved in the fluid flow is nothing but dynamics of fluid flow. What are the forces involved? We are having various types of forces like thrust force, like uh, pressure force, like turbulent force, right? So acting in the fluid in order to change the position or motion of the fluid, right? Next. So the topic is to derive the Bernoullis equation. The Bernoullis equation, yeah, slowly coming. Okay, no issues. The Bernoullis equation is derived on the basis of principle of conservation of energy. So if you get any question in the exam, state the assumptions of Bernoullis equation and derives the Bernoullis equation. Annappudu ee topic rayali. State the Bernoullis equation and what are the assumptions and derive the expression. So it is stating that it is based on the principle of conservation of energy. So it states that in an ideal incompressible flow, in an ideal incompressible fluid, when the flow is steady and continuous, the sum of the pressure energy, kinetic energy, and potential energy is constant. So ఈ definition simple గా ఏం రాశాడు? The sum of what? The sum of pressure energy P by W, the sum of kinetic energy half V square by 2G, and the potential energy Z is equals to constant simply. So it is stating that in an ideal or incompressible fluid, when the flow is steady and continuous, the sum of this pressure energy, kinetic energy, and datum energy is constant along the streamline. So that is the definition you have to write. And it is based on the principle of conservation of energy. Now, mathematically, we have to prove this one, right? Where P by W is the pressure energy, V square by 2G is the kinetic energy, and Z is equal to potential energy. So whatever the theory, whatever the definition set by Bernoulli, here also have some assumptions. And the assumptions ni base cheskone this will get valid. So what are the assumptions? E condition satisfy ఇవ్వాలంటే some of the assumptions should be proved. What is that? The flow is steady. Flow should be steady at a point, no variation of the fluid properties with respect to time. So with respect to time, the flow should be steady అన్నాడు ఫస్ట్ assumption. Second ఏంటి? The flow is ideal. The flow is ideal. So no friction losses due to viscosity. So the flow should be ideal. That is no frictional losses due to viscosity. Next, the flow is incompressible. No variation in the fluid density. So density lo variation ఉండకూడదు. And ఎలా ఉండాలి? The flow should be incompressible. So simple assumptions ఏంటి? The flow should be steady. The flow should be ideal. The flow should be incompressible. And the flow should be continuous. And velocity is uniform over the section. Whatever the section, మన pipe section తీసుకున్నప్పుడు, the velocity should be uniform over the section. For the next one, the flow is along the streamline, that is one dimensional. Should it have only in x direction, not in y direction and z direction. So one dimensions గురించి చదువుకున్నాం x, y, z and one dimension, two dimension and three dimension. So here it is saying that the streamline, the flow is unidimension, that is one dimension అంటే x axis లోనే. Sixth assumption ఏంటి? The only forces acting on the fluid are gravity forces and not on the pressure forces. So what are the types of forces acting here? The forces acting on the fluid are gravity pull and the pressure forces. Gravity forces ante natural forces, pressure forces ante through the pumping system. So ivanni six conditions satisfy aitene the Bernoullis equation whatever we are saying is correct, right? Now we'll see how the derivation glow. Now take just a pipe, a cross section pipe with a two sections. Ikkada narrow ga undi, ikkada widen ga undi. The diameters are different here. Now take a cross section of a pipe, right? Now let P is a fluid velocity at section 1. So section 1 తీసుకున్నాము. Section 1 లో P1 is a fluid pressure at section 1. Next V1 is a fluid velocity at section 1. Z1 is the datum height of the fluid at section 1. The datum line అంటే దాని కింద బేస్ లైన్, దీన్ని datum line అంటాం. ఈ కింద నుంచి పైన యాక్సిస్ వరకు ద ఎండ్ ఆఫ్ దిస్ పైప్, అదర్ ఎండ్ ఆఫ్ దిస్ పైప్, రైట్? ఈ రెండుని క్రాస్ సెక్షన్ చూసుకుంటే దట్ ఈస్ నథింగ్ బట్ ద డేటమ్ height. The Z1 is equal to height of the fluid at section 1. Similarly, P2, V2, Z2 are the corresponding values at section 2. So ఏం చెప్తున్నారు? P2, V2 and Z2 are the corresponding values at section 2 అంటున్నాడు. Now the energies processed by the fluid at section 1. So ఇప్పుడు మనం section 1 వరకు తీసుకున్నాం. At section 1, see the kinetic energy. The pressure energy is P1 by W1. P1 by W1 into S. Kinetic energy V1 square by 2G. Potential energy Z1. So the total energy at section 1 is equals to adding pressure energy, kinetic energy plus potential energy P1 by W plus V1 square by 2G plus Z1. Similarly, the total energy at section 2 same అదే తీసుకోండి. P2 by W plus V2 square by 2G plus Z2. Applying the Bernoullis equation between the sections 1 and 2, the total energy at section 1 is equal to total energy at the section 2. So in the assumption lo manam cheppukunnattu, so it should be same, steady and uniform, right? Therefore the total energy at section 1 is equal to total energy at section 2. Next, so appudu em rayali, section 1 ki section 2 ni equate cheyandi. P1 by W plus V1 square by 2G plus Z1 is equals to P2 by W plus V2 square by 2G plus Z2, right? So this is a equation. So Bernoullis equation was based on the assumption of fluid is non-viscous and therefore frictionless. Okay, these losses have therefore to be taken into consideration in the application of the Bernoullis equation, which gets modified for the real fluids. When there are real fluids, so ఇక్కడ మనకు non-viscous fluid ఉంది. ఇక్కడ when there are real fluids, P1 by W V1 square by 2G plus Z1 is equals to P2 by W plus V2 square by 2G plus Z2 plus HL. HL is equal to loss of energy between the section 1 and section 2. Section 1 ki section 2 ki loss of energy, right? Whenever there is a loss of energy, we have to add plus HL, right? So this is a derivation how to do the Bernoullis equation, right? Very simple and straightforward derivation. When it comes in the question, state assumptions, you have to write these assumptions and derive the expression for Bernoulli అన్నప్పుడు ఈ problem ఈ derivation చేయాలి. And what are the limitations? The velocity of our liquid particle in the center of the pipe is maximum, right? Second one, the turbulent flow. In the turbulent flow, some kinetic energy is converted into heat energy. So whenever there is a turbulent flow in the pipe, the kinetic energy edaithe undo, it is converted into heat energy, and the viscous flow, some energy is lost due to the shear forces. So turbulent energy జరుగుతున్నప్పుడు boundaries ki, ఆ pipe boundaries ki water ki shear జరుగుతుంది. Shearing action జరిగినప్పుడు there is a loss in the energy. Thus, while using Bernoullis equation, all such losses should be neglected, right? So which is not happened in actual practice. So practical ga jaragavu kabatti, so it should be neglected. Next, there are always some external forces acting on the liquid. There are always some external forces acting on the liquid which affects the flow of liquid. Thus, while using the Bernoullis equation, such external forces are neglected. So pratidaniki we have to say that Bernoullis equation are neglected. So which is not practical into taken into account. Next, if the liquid is flowing through the curved path, the energy due to the centrifugal force should be taken into account. So when the liquid is flowing through any bend, pipe bend, so a pipe bend దగ్గర liquid వెళ్తుంది అనుకోండి, at that point we have to take the centrifugal forces. So at that point we have to take the centrifugal forces into consideration. So this is a concept, the velocities, limitations and assumptions of the the Bernoullis equation, right? So I think only 4 students maybe in this class till the end. So we'll have a small motivation video because you are civil engineering students. Just I will show a small motivation video which will be useful and which will be motivation for you, right? Yeah. So this is dedicated to all the civil engineering students. Just have a motivational video. Hope you are watching the video. Yes. So you have watched the video, very interesting video, right? So this is a famous architects around the world, but yesterday, today, or today in the WhatsApp also I have seen Mokshagundam Visvesvaraya, who is a legendary engineer in civil engineering, the first civil engineering in India, was born in 1912 in Chikballapur district, Karnataka. So he's a famous architect, civil architect, who has worked in a high position in Mysore Maharaja Palace, and he has the greatest reward, Bharata Ratna Award, right? You know that many of the people know that Bharata Ratna Award, right? So, and also he is famous. He is famous for his excellent architects. So, if you see in India, Mokshagundam, not only in India, in other countries also, Mokshagundam Visvesvaraya have given the excellent design. So, for small examples, if you see the Tirumala Tirupati Ghat section. So, Tirumala Tirupati temples వెళ్ళేటప్పుడు Tirupati. So you don't have any AutoCAD drawings, you don't have any software, you don't have any drone technology, you don't have any sky camera, video camera, how to see the mountain. So in the 7 hills, without any technology, he has given a road map how to go up one side, how to come down other side for this 7 hills. So that is an excellent architecture given by the our Mokshagundam Visvesvaraya. And also, if you see one of the universities, Sri Venkateswara University, Tirupati, also, if you see the university, inside you are having the maximum, the total design is given by the Mokshagundam Visvesvaraya only. All the location, canteens, hostel, college, main building, administrative building, everything is designed by him only. And if you see the canteen, if you see the auditorium of the SV University, totally it is totally different from other university auditoriums. It is just like a design of a drum, just like a శివుడి చేతిలో ఉన్న డమరుకం. సో ఇఫ్ యూ సీ ద డమరుకం, దాన్ని హాఫ్ కట్ చేస్తే ఎలా ఉంటుంది, యాక్సిస్ హాఫ్ కట్ చేసి గ్రౌండ్ మీద పెడితే ఎలా ఉంటుందో, దట్ ఈస్ అ డిజైన్ మేడ్ బై విశ్వేశ్వరయ్య ఓన్లీ, రైట్? అండ్ ఇఫ్ యూ నో the Kaveri River, where the Kaveri River is located, the Kaveri River is located in Karnataka. So here he has also given a plan and design and architecture construction of the reservoir of Kaveri River. So Kaveri River reservoir pakkana you are having a big park, a big entertainment park known as Brindavan Gardens, located in Mysore. Future if you want to go and visit, if you see the Mysore Brindavan Gardens. So Brindavan Gardens pakkane you are having a big reservoir known as Kaveri River Reservoir. Just like your Srisalam Reservoir laga, you are having ఆ సైడ్ ఖాళీ స్థలం ఎందుకు వేస్ట్ చేయడం అని చెప్పేసి he took around 30 to 40 acres of land and he gave a design for a big park, a big national park. So old movies, Tamil movie, Telugu, Kannada, other movies, majority of movies, songs and you can see in that Brindavan Gardens only. The layout is excellent layout. Behind the reservoir, you are having a big park. So these are the things you can see in India done by the Mokshagundam Institute, right? Okay, so just an information given to you. So okay, come back to the class. Hope you understood the talent of an engineer and understood the engineering subject value, the civil engineering or mechanical triple or whatever. If anyone want to do miracles, definitely he want to do some research, right? Okay, come back to the real world. So based upon the Bernoullis equation, we'll solve some problems. So these are very quite interesting, easy problems. So if you practice this once or twice, easily you can understand the problems. Okay, now see, a pipe through which the water is flowing is having the diameters, Yes. Yeah, so if you see, so I'm taking a pen. A pipe through which the water is flowing having the diameters 20 centimeters, 20 centimeters and 10 centimeters at the sections 1 and 2 respectively. The velocity of water section 1 is given 4 meters meter square. Find the velocity at section 1 and 2 and also the rate of discharge Q. So this is a quite straightforward question. So the diameters at section 1 is D1, 0.2 meters. Therefore find the area automatically. You are getting the value 0.03. Then if you see the velocity V1, that is 4 meters per second, right? That is given in the question. Then what is the T2? 0.1 meter is also given in the question. Then find the A2, you got the value. Now at the section 1, find the potential energy, that is find the kinetic energy, V square by 2G, V1 square by 2G. That is a value. Now at the section 2, find the kinetic energy. So V2, then to find V2, we have to go for the continuity equation. V2 తెలియదు కాబట్టి. So by using this continuity equation, ఈ equation ముందు classes లో చెప్పుకున్నాము. That is A1 V1 is equals to A2 V2. Substituting in that, we will get the value of V2, that is 16. Now applying in that, we'll get the section 2 value, that is 13.5. Now the rate of discharge is Q is equals to A1 V1 or A2. ఏదో ఒకటి తీసుకోవచ్చు, A1 V1 or A2 V2. Therefore Q is equals to A1 V1. Substituting the values in that, you are getting 125 liters, 124.6 liters per second. That is a rate of discharge, right? The questions are quite easy. The problems are quite easy. If you practice once, automatically you will come to know the remaining things also. Next, the water is flowing through the pipe having the diameters 20 centimeters and 10 centimeters at sections 1 and 2 respectively. The rate of flow through pipe is 35 liters per second. The section 1 is 6 meters above the datum line and the section 2 is 4 meters above the datum line. If the pressure at section 1 is 392, find the intensity of the pressure at section 2. Okay, now if you see here, the pipe is in other direction. You are having the cross section 1 is wide open, the section 2 is very small opening. So from this figure you can say the datum line for section 1 is 6 meters, the datum line for section 2 is 4 meters. So by writing the given data, D1 is equals to 20 centimeters. Taking the area, you are getting the value. Next, you know the datum line for A1 is equal to 6 meters. Now take the section 2, D2 is equal to 10 centimeters. A2 is equals to pi by 4 D2 square. You are getting the value of A2. Then what is Z2? Z2 is equal to 4 meters. Now the rate of flow Q is equals to 35 liters per second. Okay. Now what is the rate of flow Q is equals to A1 V1 is equals to A2 V2. V1 is equals to, so after getting the value V1 is equals to 1.1 meters per second, V2 is కొంచెం ఫాస్ట్గా చెప్తున్నాను ఎందుకంటే you know the problems, right? So V2 is equals to Q by A2. We got the value V2. Now apply the Bernoullis equation section 1 and 2. Apply the Bernoullis equation, P1 by W plus V1 square by 2G plus Z1 is equals to section 2. Now applying all the values in that, you are getting P2 value is equals to 402. సో ఇక్కడ మనకి ప్రెషర్ ఇవ్వలేదు. ముందు ప్రాబ్లంలో మనకి V2 కనుక్కున్నాము by applying the constraint equation. Here we are supposed to find P2. సో P2 కనుక్కోవడానికి మనము Bernoullis equation అనే కాన్సెప్ట్, the formula we have took in this problem, right? Hope you understood the problem here. Next, a long 6 mm pipe, a 6 meters long pipe is inclined at an angle of 20 degrees. So ఇక్కడ angle ఇచ్చాడు, angle problem. So a 6 meters long pipe is inclined at 20 degrees with the horizontal. The small section is inclined at a lower level 100 mm diameter and the larger section of pipe is 300 mm diameter as shown on the figure. If the pipe is uniformly tapering and the velocity of water in the small cross section is 1.8, determine the differences of pressures between the two sections. Determine the differences of pressure between the two sections. So here it is the datum line. Datum line nunchi a pipe is making an angle of 20 degrees. The section 1 is a small diameter pipe, section 2 is a large diameter pipe. At section 2, the datum line is given as Z2. The total pipe length is 6 meters. So what to find out? Find out the pressure differences between the two sections. So we have to find P1 and P2 by applying the Bernoullis equation, right? Next, given the data, length of the pipe is 6 meters, angle of inclination is 20 degrees. Now the section 1, D1 is equal to 100 mm, that is 0.1 A1. So after getting first D1 వచ్చిన వెంటనే ఏరియా కనుక్కోండి. Next V1 is equals to 1.8 meters per second. Z1 is equals to 0. So at section 1, Z1 is equals to 0. Now take at section 2, D2 is equal to 300 is given. Find A2. Therefore Z2 is equals to, what is Z2 here? It is making 20 degrees. So make a triangle. Then you are getting Z2 is equals to 6 sin theta, right? 6 sin theta. 6 sin theta is equals to theta. What is the angle? Theta is equal to 20 degrees. 6 sin 20 degrees is equal to 2.5 meters. So ఎలా వచ్చిందో తెలుసు కదా, just like your hypotenuse formula. So మనకి triangle వేసుకోండి ఇట్లా. So after making a triangle, so this one is a theta. Okay, the time is running out. Theta. So opposite by hypotenuse. That is a thing you got. Therefore 6 sin 20 the value. Now the difference between the pressures between two sections P1 minus P2. So from the continuity equation, first find out V2 or V1. A1 V1 is equal to A2 V2. Therefore V2 is equals to, we got the value. Now applying the Bernoullis equation, normal Bernoullis equation, that is P1 by W. This one, what you are getting? P1 minus, so keeping aside P1 P2, keeping other things aside, just interchange the values. So on substitute as usually, we are getting the value of P1 minus P2 is equal to 1.88 W. So we know that W is equals to 9.81. Therefore P1 minus P2 is equals to 18.44. So question lo em ichchadu, find the pressure difference annadu. Find the differences in the pressures between the two sections. So pressure 1 pressure at 1 or pressure at 2 ante separate ga P1 gaani P2 gaani kanukoవాలి. ఇక్కడ ఏమన్నాడు, find the differences of pressures between the two sections అన్నాడు కాబట్టి P1 minus P2 we have calculated. Now where we are using this Bernoullis equation. Bernoullis equation is applied in all the problems of compressible flow where energy considerations are involved. ఎక్కడైతే energy considerations ఉన్నాయో in the channels in the incompressible flow, the Bernoullis equation is used. But we shall consider its application depends upon for the following measuring devices. So based upon the devices, by using the devices, we can also go with the applications of Bernoullis equation. So what are these devices? First one is a venturi meter, second one is orifice meter, third one is a pitot tube. So ee topics gurinchi manamu fourth unit lo we will discuss these topics, right? So ee measuring devices gurinchi manam fourth unit lo manamu detail ga discuss cheskundam, right? Next, Bernoullis equation from Euler's equation. So Euler's equation మనం ముందు క్లాస్ లో చెప్పుకున్నాము. Now Bernoullis equation from Euler's equation. So Euler's equation నుంచి how to get the Bernoullis equation, right? Now see, The Bernoullis equation is obtained by integrating the Euler's equation of motion. So what is this one? dp by p plus g dz plus v dv is equals to constant. Okay. Now integrating this one, we are getting p by rho plus z z plus v square by 2, that is equal to constant. దాన్ని మనం ఎలా రాయొచ్చు? p by rho g plus z plus v square by 2g, that is equal to constant. Or else we can write p by rho g plus v square by 2g plus z is equals to constant. So equation 6.4 is Bernoullis equation. Same ide manaki p by w chepparu kada. So here w is equals to rho into g. Already మనకు తెలుసు. So just ఇక్కడ p by w అంటే w is equal to rho g, half mv square laga half v square by 2g plus z is equals to datum energy. So it is a potential energy, it is a kinetic energy, this is a datum energy is equal to constant. Now equation in which p by rho g is the pressure energy, v square by 2 is the kinetic energy, z is equal to potential energy, right? Next. So now see the other problem. So water is flowing through the pipe having the diameter 300 mm, okay, and 200 mm at the bottom. So పైన diameter వచ్చేసి 200, కింద diameter వచ్చేసి 300, and the intensity pressure at the bottom end is 24.525. Pressure at P2 section is 9.81, right? Now determine the differences in the datum line. So ఏం అనుకోవాలి మనం? Z1 Z2 అనుకోవాలి, right? So ఇలాంటి problems లో you can solve any type of parameter. P కనుక్కోవచ్చు, Z కనుక్కోవచ్చు, V కనుక్కోవచ్చు, right? సో ద ప్రాబ్లమ్స్ విల్ బి ఇక్కడిక్కడే తిరుగుతుంది. P కనుక్కోమంటాడు, అన్ని ఇచ్చి P కనుక్కోమంటాడు, అన్ని ఇచ్చి Z కనుక్కోమంటాడు, అన్ని ఇచ్చి V కనుక్కోమంటాడు. జస్ట్ ఈ విల్ షఫిల్. సో మీకు స్కోర్ చేసుకోవడానికి ఇట్ ఇస్ ద బెస్ట్ ఆప్షన్, రైట్? నౌ సీ ద datum line. If the rate of flow Q ఇచ్చేసి 40 liters ఇచ్చేసాడు. Now write the given data, write the diagram also. D1 300, P1 given, D2 given, E2 given. So the areas automatically you can find, you can solve here. ikkada ichchaadu solve chesukomani, but you can solve here the area here also, right? D1 వచ్చినప్పుడు వెంటనే కనుక్కోండి, D2 వచ్చినప్పుడు ఏరియా వెంటనే కనుక్కోండి. Now what is the rate of flow? 40 liters by second అన్నప్పుడు 40 by 1000 is equal to 0.4 meters లో కన్వర్ట్ చేసుకోండి. Okay, now applying the continuity equation. సో మీరు రాయాలి అప్లయింగ్ ద కంటిన్యూటీ ఈక్వేషన్ a1 v1 is equal to a2 v2. సో ఏదో ఒకటి. సో మనకి ఇక్కడ ఏముంది? సో బై టేకింగ్, సో వీ హ్యావ్ టు ఫైండ్ a1 అండ్ a2. సో మనకి రేట్ ఆఫ్ లో ఇచ్చాడు కాబట్టి a1 v1 is equals to 0.04 కనుక్కుంటే v1 వస్తుంది, a2 v2 is equals to 0.04 కనుక్కుంటే v2 వచ్చింది. Now what to do? So we got v1 d1 p1. Now applying the Bernoullis equation for 1 and 2, pressure energy plus kinetic energy plus datum line is equals to pressure energy, kinetic energy plus datum energy at 2. So దీనివల్ల ఏం కనుక్కోవాలి మనం? You have to find Z1 and Z2. Now substituting those values directly here. So Z1 Z2. So substituting, we are getting the values like this. So itla values వచ్చిన తర్వాత, so Z1 Z2. Now so రెండిట్లో, so take Z2 here or Z1 that side. Z2 minus Z1 is equals to 25 minus 11, that is equal to 13.67. 67 and 69 అంటే 70, 13.70 meters. Now what is the difference in the datum line? Z2 difference in the datum line, Z2 minus Z1 is equals to 13.70, right? So you are having some more slides, no issues. The balance unit 3 లో starting లో చెప్పుకుందాము. So I think the time is very short where we are. Yeah, so ఈ 6th problem చెప్పుకొని we'll stop. Okay, yes. The water is flowing through the taper pipe of length 100 meters having diameter 600 mm at the upper end and 300 mm at the lower end at the rate of 50 liters per second. The pipe has a slope 1 in 30. Find the pressure at the lower end if the pressure at higher level is 19.62 Newton per centimeter square. So given data, write down what is the length 100 meters, what is the T1, area, P1, that is a 19.62. So slope ఎంత ఇచ్చాడు 130 ఇచ్చాడు, right? So diameter of the lower end D2 is equals to this one, A2 is a given. So Q rate of flow is equal to 50 liters ఇచ్చాడు, convert చేసుకుంటే meters cube by second. Now let the datum of the line that the datum line pass through the center of the lower end, then Z2 is equal to 0, right? So here Z2 is equal to 0, datum line passing through the center line, Z2 is equal to 0. Now the slope is 130, we have to take Z1 is equal to 1 by 30 into 100. So the converted into meters kabatti 1 by 30 into 100, that is 10 by 3. Therefore Q is equals to the momentum equation, Q is equals to A1 V1 is equals to A2 V2. Therefore find V1 and V2 values, right? A1 V1 is equal to Q cheste V1 vastundi, A2 V2 is equal to Q cheste you will get V2. Now applying the Bernoullis equation directly, this is the Bernoullis equation, right? Now substituting the values in all this one, Z10 is equal to 10 by 3, Z2 is equal to 0. So substituting this one step by step, step by step, step by step, we are getting P2 value, we are getting, so rho మనకు తెలుసు 1000, G మనకు తెలుసు 9.81. So P2 is equals to this one. So finally we have got the pressure at level 2. So with this we'll stop the class. The time is very short. So hope you understand these topics, right? So I'm taking the attendance. మీరు కూడా ఒక స్క్రీన్ షాట్ తీసి పెట్టుకోండి, maybe useful for you. So once this video is uploaded in the YouTube, I will send this link to you. Please open the link in your group and just view it, like it. చాలా మంది లైక్ చేయట్లేదు, మీ డిపార్ట్మెంట్ మేనేజ్మెంట్ చూస్తారు. జస్ట్ లైక్ ఇట్, లైక్ ఆర్ డిస్లైక్ యాజ్ యువర్ విష్. లైక్ సింబల్ ఉంటుంది, హ్యాండ్ సింబల్ అనేది అప్ డౌన్, జస్ట్ మీరు ప్రెస్ చేశారంటే కలర్ మారుతుంది, రైట్?